Hello, Namaste, Ram Ram, Sat Sri Akal, Vanakkam. Many NEET aspirants are constantly telling me to simplify NCERT physics chemistry to such extent that it is very easy to memorize and remember the facts of NCERT for a long time. I want you to comment down your doubts and suggestions. I will surely feature them in my future videos. Please like and subscribe. So let's start. This is the physical world, and here it is given what is physics and like this stuff, like what is science. You know all this already, as you have taken science in class 11 and 12. And what is scientific method? Science is a systematic approach. You all know this very well. So what is physics? Here it is given. Now this part is important as it talks about unification and reduction. This approach of reductionism is the heart of physics, chemistry, and biology. In biology, you will study about an approach called reductionist biology. So here you can see it has been given an introduction of Ernest Rutherford, which you will study in class 12. In Bohr model, this Bohr model you will also study in class 12 and class 11 chemistry, class 12 physics and class 11 chemistry. Here it is given scope of physics. This is the classical physics. Classical physics deal with macroscopic phenomena and include mechanics, electrodynamics, optics, and thermodynamics. Mechanics are based on Newton's laws of motion, laws of gravitation by Kepler and Newton combined, motion of the particles, and general system of particles, like the propulsion of a rocket by jet of ejecting gases. I will teach you this in my future videos. Next, electrodynamics deal with electric and magnetic phenomena associated with charge and magnetic bodies. These are based on the law of Coulomb or Stud. We will study them in the future videos. Coulomb or Stud and also Faraday. This is the experiment done by Rutherford and his student Geiger and Marsden. Here it is written Ampere Faraday. Maxwell. Maxwell gave theory on lights. Now in this part, optics. Optics is also a huge area of excitation. Here some data is given. Remember this one. And this is the scale of time. And this is the range of masses. Okay, remember this. 10 to the power minus 30 kg is approximately the mass of an electron. That is 9.1 into 10 to the power minus 31. Now this part you give a reading, and now all this you will learn in the future. Now what is hypothesis, axiom, and models? Hypothesis is just an assumption given by Newton and several other scientists. Here it is given the definition of hypothesis. Hypothesis is a supposition without assuming that it is true. An axiom is a self-evident truth, while a model is a theory proposed to explain an observed phenomenon. Okay. In mathematics, we need axioms and hypotheses at an early stage. Elusive statement is also a hypothesis. The connection between physics, technology, and society can be seen in many examples. Here it is a reference of steam engine in Industrial Revolution. While Ernest Rutherford has dismissed the possibility of tapping energy from atom, but only a few years later, Hahn and Meitner discovered phenomenon of neutron-induced fission of uranium, which would serve as the basis of nuclear power reactor and nuclear weapon. You people know that once Einstein also denied the fact that the nuclear power reactor can be made, but it was made. So this is the important fact. You have to memorize this. Don't memorize this. Don't memorize the dates. Only memorize who did what. Okay. Now this is the development of alternative energy resources like solar energy, geothermal energy into electricity. Just give a reading through this chart. Don't memorize this now. You will obviously memorize this later on. Okay. If you are starting in class 11, don't memorize this, and one who have done his class 12, he know most of this. Okay. So the most important part of this chapter, fundamental forces of nature. There are actually 4 fundamental forces in nature. The correct notion of force was arrived by Isaac Newton, who gave his research only on gravitational attraction of two bodies. And Aristotle had wrong ideas about the force. In macroscopic world, beside gravitational force, we will encounter these are mostly in form of this gravitational force or electrostatic force. So these are not new forces, but these are the forces which are generated either by potential due to gravity or electrostatic energy. Now most people know all this. Now starting with the gravitational force. Gravitational force is the force of mutual attraction of two bodies by the virtue of their masses. This is a universal force, and most forces are considered to be gravitational forces. It is a weak force, but it plays a key role in large-scale phenomena of universe. Electromagnetic force. Electromagnetic force is a strong force. At least it is stronger than the gravitational force. It is the force between the charged particles. This force equation is given by the Coulomb law, and it is enormous compared to gravity. It is approximately 10 to the power 36 times the gravitational force. Electromagnetic force dominates all phenomena at atomic and molecular scale, but at macromolecular scale, gravitational force is the most important. But at molecular scale, the electromagnetic force is the most important. Gravity is always attractive, while electromagnetic force can be attractive or repulsive. Now just read this about Chattendranath Bose, Bose-Einstein statistic, Bose-Einstein considerate models. See. Now next, strong nuclear force. Strong nuclear force binds protons and neutrons in a nucleus. It is evident that without some attractive force, the nucleus will be unstable due to electric repulsion between the protons. Neutrons are neutral, so they have no charge. So there must be some negative charge, but there is no negative charge in the nucleus of an atom. So the positive charge have to be arranged in some way that they are stable inside a nucleus. So this work is done by a strong nuclear force. It is an attractive force. It is about 100 times that of electromagnetic force in strength. It is charge independent and acts equally between proton and a proton and a neutron and a neutron and a proton and a neutron. The range is extremely small, about that of nuclear dimensions. It is responsible for the stability of nuclei. Electrons do not experience this strong nuclear force. Recent development have, however, indicated that proton and neutron are built still more elementary constituent called quark. Remember this one. Now next, weak nuclear force. Weak nuclear force appears only in certain nuclear processes. So if you are mentioned only nuclear force, then which one you will select? Strong nuclear force or the weak nuclear force? You will obviously select strong nuclear force and reject weak nuclear force. Weak nuclear force is not attractive. It is repulsive in nature. Here see, nucleus emits electron and an uncharged particle called neutrino. Weak nuclear force is not as weak as gravitational force, but it is weaker than strong nuclear and electromagnetic forces. The range of weak nuclear force is 10 to the power minus 16 meter. So it is a general fact that gravitational force is weaker than weak nuclear force, which is still less than electromagnetic force, which is again still lesser than strong nuclear force. So next, here's the order. I had told you about the reduction policy which is played in physics, chemistry, and biology. So all scientists want to find out some similarity between two laws. Such is the advances in the force part of physics. scientists want to unify different forces. There is gravitational, weak nuclear, electromagnetic, and strong nuclear forces. Oersted and Faraday had already showed that magnetism is nothing but an electric phenomenon. Einstein had attempted to unify gravity and electromagnetism, but could not succeed in this venture. Many other scientists had also tried to do the same, but they were unsuccessful, and still no one has been very much successful in unifying all the forces of nature. Maybe some of few people would unify the forces of nature. So, nature of physical laws. Physicists explore the universe. Their investigation based on scientific processes, ranging from particles that are smaller than atom and to the stars that are very far away. In any physical phenomenon governed by different forces, several quantities may change with time. For motion under external conservative force, total mechanical energy, that is sum of kinetic energy and potential energy of the body, is constant. So this will never change in its life. In this part, if you see, Einstein theory suggests mass is equivalent to energy as E equals to mc square, where c is the speed of light in vacuum. Nuclear processes, mass gets converted to energy and vice versa. This energy, which is released, can be used in nuclear power generation and nuclear explosions, as in nuclear weapons. Here is written about the thermodynamic part of physics, which you will study in the thermodynamics chapter of class 11. Here read about Sevi Raman. Just give a reading. Here see, energy is a scalar quantity. Energy is not a vector quantity, but it is scalar quantity. But not all quantities that are conserved are scalar quantities. This linear momentum and angular momentum are vectors, but they can be conserved in isolated system or a system without any torque acting on it. Now see this. Pauli predicted in 1931 the existence of a new particle called neutrino emitted in beta decay. You people give a reading to this one and this one. And here notice that acceleration due to gravity at moon is 1/6 that of Earth. This will play a key role in solving many questions of gravitation. But the law of gravity is same in both. Next, this is a summary. Just give a quick reading of it. And here the exercise is not given for formal examination, so we will not discuss them and not waste your time. So thank you guys for visiting my channel. Please like, comment and share this video with your friends, and thank you.